everybody. I'm Kyle Crowling. I'm a sophomore at Gull Lake High School and a student in the Computer Science and Software Engineering class. Today I'm going to show you how I coded my Sphero Bolt along with my partner, William Holmes. So if you look here, this is where it starts. It all starts out with this async function start program. This is telling the Sphero Bolt to sync up with the rest of these commands, like the function. This is telling it to follow this next line, which means to start the program. After this, it follows all of this code down here, and this code above, which I will get to later. So if you look here on the right side of the monitor, you can see that is our Sphero Bolt. Might be a bit grainy because of resolution changes and all that sort of thing, because resolution on YouTube is not the best when it is a enlarged picture or manipulated at all. So if you look here, that's Sphero Bolt. It is colored green right now. Our first commit was to make it roll and then turn purple right there. So we don't actually know how far it is supposed to send it. We just did a process of trial and error. We set the speed to different lengths because if we changed this number here, which was supposed to be the distance, it did not like to follow what we wanted it to do. It would keep going and it would not stop. So, in exchange, we changed the speed of it, and that eventually worked. So, then we have here, if get location, if x equals 70, which is it just going straight down, it will set the LED to that shade of purple there. And then it will wait 5 seconds before going to the next area. So, as you can see here, if I rewind it again, and it waits 5 seconds, then it rolls over, turns and rolls over to the screen section, as you can see there. Now you can see the code over here. This await roll command. After the 5-second delay, it waits, well, for, of course, 5 seconds. I didn't mean to repeat myself, but I did. Alright, so then it tells it to turn 90 degrees to the right. Tells it at a speed of 46. That way it would come here exactly. The distance stays the same throughout this entire process. So I'm only going to go over that once. So then if get location x equals 70, I'm not sure why that's there. I'm going to be completely honest. William just added that so he could be fancy. It is unneeded though. And then, once it got to that location, it would set the main LED light to green, 255. Then it would wait 5 more seconds to go here. We found most of our stuff, most of our code ideas from the Sphero EDU wiki, which is linked on my ePortfolio, and it will be under the under these videos. So, you can see movement. These can be coded in both Python and JavaScript. We use JavaScript for this. So all of these are in JavaScript. So we use all these commands. We did not use the roll to distance. We just did, where is it? Okay. We just did await roll because it was much more simple and the roll to distance was bugging out for us. It did not like to work. And then we use the set main LED to change the lights to those colors. So if we go back here, we can see it turns 90 degrees to the right and then goes here like it does in the code. Then, again, it'll wait 5 more seconds now to go and do the music. So, it goes here, turns, goes there, As you can hear, it displayed a fireworks sound effect. And then it stays there for a good couple of seconds, about 5 more. So as you can see, has it turning about 108, well, has it turning about 180 degrees from this location, because these bolts, they like to be weird with the angles they turn at, and that just worked for us for some reason. Oh wait, no, I remember now. Okay, so how it works is it specifies from where it started. The turning is from wherever it started facing. So if you turn it 90 degrees from then, it will turn 90 degrees. If you say turn 90 again, it will stay turned at that angle. But if you say 180, it will add on another 90 degrees to it, causing it to turn like that. Then 220, making it go over here, play the audio, then roll over here, over to our emoji, which was an animation. You can't see it that well, but it did work. And we have that blue. So I'm going to stop right there. So then it plays the sound effect right here, as it says await sound effects, dot fireworks, dot play, false, await delay 5. Next up, it makes it roll 90 degrees, again, back to the original one. Then 45 degrees again to make it over here. Then we have up here. This is to register the matrix animation. That is what it was called. I changed all of these numbers individually myself, and these ones equal turned off pixels. These sixes are all white pixels. Or, well, these sixes are all yellow pixels. Correction. Alright, then this palette. This just what colors to what numbers. Then if we go back down here, we have the play matrix animation. This makes it so that it will go over here, and it will actually do the animation itself. So for this, for our animation, we used the matrix animation to make a winky face, because that is what the emoji on the ground is. So, as you can see, eyes winking at you, and then it continues on until it can change colors. This is our file management. Well, this is GitKraken. It is what we used to ensure our files from our computer will link to the files on GitHub. So as you can see, it has play matrix animation true. It waits 5 seconds, and then it will stop the animation. Then it will make it roll 120 degrees, and then 190 to make it go to this checkpoint here. I understand that it might not look like it's there, but our teacher says it counts, so we counted it. And then it turns blue using the same type of function up here. Then it waits 5 more seconds, rolls over here using this code, 105 degrees, 20 speed, 2 something, turns orange. Then sets the color to orange. Does the get location thing, which William wants to make fancy or something. I don't know why. He just likes to. Then we have it rolling clockwise at 360 degrees, as you can see there. We have it going from orange to the counterclockwise, starts spinning immediately. Then it waits 5 more seconds. It will roll over here to that. It's in the vicinity. So then we have our audio.
Again.
Okay, let me rewind it a tiny bit.
Ah, it's on the black lion again.
William thought it didn't count, but it did. And then we have it going over here, spinning again, and then turning green to finish off the maze. So we had the laser sound effect, we had it wait 5 seconds, and we had it roll back up to the very end, spin a couple times using these roll commands, because for some reason the original spin command didn't want to work. And then we had it turn green at the very end. Again, all of this is on the Sphero EDU wiki, which is linked to my profile, as well as the Sphero Bolt website, which I don't currently have open. In fact, I can open that up real quick. On this website right here, where you can see, you can sign in, you can connect to the Sphero Bolt from a laptop or your phone, and then you can start coding in here. Both of these will be linked to my website. So, thank you for watching. I hope you have a good day, and please make sure to like and subscribe to further my career.